Okay, let's look at problem 3. So in problem 3, let's say we have a EMG control system where you're controlling the artificial hand, okay? So something like, so let's say this is your artificial hand. Excuse my bad drawing. And you have EMG systems on 4 different muscles, right? So you are having, so that's one EMG system, two, three, four. So let's say M1, M2, M3, and M4. And depending on whether the muscle is being activated, you get some digital signals. And then there are 4 conditions in which we want a particular function of the artificial hand to be done. So here's a logic, a digital logic, and these inputs are basically feeding into it. And what we are saying is this controls a particular function of the hand. When is this function going to happen? Right? And we have been given conditions in words that we want to convert into a truth table. So let's say whenever one of the muscles gets activated, we say that's the activated muscle is equal to 1. It gives an output of 1. If it's not activated, we get 0. Okay. So for each of the muscles. So we have 4 inputs to our system, M1, M2, M3, M4, and the output is a function f. Okay. And again, we write what are the conditions when we want the function to work. So it says the first condition is that the muscle 1 is activated. That is, whenever muscle 1 is 1, it doesn't matter what the others are, we want this to be 1. The second condition is muscle 2 is not activated. No, wait a minute. A, B, and C are conditions that need to work in the same time. So muscle 1 is activated and muscle 2 is not activated, which means my x's are wrong, right? So you want the muscle 2 to be 0 and muscle 3 and muscle 4 are in the same state. So which means either it is 0, 0 or it is 1, 1. So in these two states, you want the function to be 1. And then the function also must be done when all muscles are activated, right? So when, so 1, 1, 1, 1, you want 1. In all other conditions, you want your output to be 0. Now so this is not a truth table, right? This is just we've written the conditions when f is going to be 1. Now we start to write the truth table, and the truth table, what we'll have to do is we'll say m1, m2, m3, m4, and we'll write all the combinations of this. So starting with 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, and so on and so forth. And when we get this combination or this combination or this combination, the outputs are going to be 1. Otherwise, f is going to be 0 everywhere else. So that would make the truth table. Okay, and you can look at the solution and see the full truth table after you've tried it, after you've tried to do it. We'll do the rest of the problem in the next few weeks.